Thank you all. So I could not be more gratified to follow Trina and the presentation of her work, because it really is going to touch on a lot of the same themes that I'm going to cover in what is the cost of being wrong, and specifically why does community involvement matter so much. The other thing I considered titling my talk, and so I just gave myself 2 title slides, is what makes a good classification problem? And hopefully by the end of my 13 minutes or so, it'll make sense why all of those questions are connected in my head. But first, I want to tell you just a little bit more about our organization, the Human Rights Data Analysis Group, or HRDAG. We're a small nonprofit based here in the Bay Area. We're a team of data scientists, and we partner with human rights advocacy organizations to identify questions or arguments that can be advanced through more rigorous data analysis. Now, over the past 30 years, we've been very fortunate to partner with a wide variety of organizations, everything from large international institutions like the United Nations and Human Rights Watch and Amnesty International, to local organizations working in the communities where they're based, like the Invisible Institute and Trina's team. Now, I like to start my talks with this quote from my colleague and co-founder, Dr. Patrick Ball, because much like Trina said, it really sets the stage for the topic we're going to cover. And that is that human rights stories tell about the worst events that anyone can experience. Taking responsibility for human rights information means assuming an obligation to the witness, to the families, and to the victim. We are morally obligated to do the best work that's technically possible so that the victim's story is heard and believed. And on our team, we are data scientists. We often go all the way to the end of a rabbit hole about a mathematical assumption or debugging a piece of code, but we never lose sight of the reason why we're so focused on those technical pieces is because we've assumed this moral obligation to do the best work we can to honor and respect the stories that have been shared with us. Now, we use a wide variety of analytical tools. Today, I'm really only going to talk about the first one, machine learning models. But if you want to learn more about the different applications and the different methods that we use and dig into more details, I really recommend that you check out the Tech Corner on our website. That's where we have more technical blog posts. A lot of those are written in Jupyter Notebook. They include code snippets, and we get into a lot more detail of our work. And in particular, if I've timed it right, I'll be able to circle all the way back and talk about that first one, processing scanned documents for investigations of police violence, and we'll link back to some of the points that Trina was making. But I want to start with some work we did in Mexico with partners at Data Cívica. And these partners came to us because it's quite common in Mexico, unfortunately, for what are called fosas clandestinas, or clandestine graves, to be discovered. These are essentially anywhere outside of a cemetery where multiple bodies are found. And the question our partners brought to us was, would it be possible, using some kind of mathematical model, to predict where those graves are likely to be found, but haven't been yet, so that we can strengthen our advocacy for investigations to look for these hidden graves? And so we thought of that as potentially a classification problem. And translating that into the language of a classification model, we said, well, we're going to need some labeled data. We're going to need some municipios, or states, within Mexico where we know these graves have been found. And then the really hard part, we're going to need some municipios where we're confident they don't exist. Not just that they haven't been found, because the absence of evidence is not evidence of absence. We need to be sure that they aren't there. And this is one of the many reasons why we rely so much on our community partners, because it's our partners who have the local context to say, we know which geographic areas that is. We can make that list of places where we think these graves, in fact, will not be found. And then we can build, or we can try to build, a machine learning model that labels the rest of the municipios, that predicts the probability of finding an up until now undiscovered hidden grave. And so we built such a model. We pilot tested it with some information from 2015. And when we showed, this is just raw results to our partners, of the top 10 municipios with the highest probability of containing an undiscovered hidden grave, our partners kind of shrugged and said, well, that makes sense. That's where the violence is happening. That's where we would expect them to be. And so we said, well, is this useful to you? And they said, oh yes, this is very useful, because now it's not us advocating for these investigations. It's this model that says this is where we should look. And so that's very useful to our advocacy. And that's an improvement on the current status quo. And I'm just going to pause that story there and switch to my counterexample, which is another classification model. This is work that my colleagues Christian Lum and William Isaac did and published in 2016 in Significance magazine, critiquing a specific so-called predictive policing model. And the goal of this model was to classify geographic regions where crime was likely to happen, so that police could prioritize going to those geographic regions. But the labeled data for this model, the training data, is crime known to police. And so what Christian and William showed using data from Open Data Oakland was they compared, on the left, the red shading is drug crimes in Oakland known to the police. And the blue shading on the right is self-reported drug use from a nationally representative health survey. Now, we can have a philosophical argument about what drug use should constitute a crime. That's not the point of this slide. The point is to show that the red shading and the blue shading have essentially no correlation with each other. And so if you build a classification model with the training data from the red shading, at best, it's going to replicate that bias, and it's going to send police back to those same neighborhoods over and over again, and not recommend sending them anywhere else. And at worst, depending upon the way the model itself is built, it may exacerbate that bias, and it may continue to over-police those neighborhoods even more. And this is the point at which I like to remember that we have in fact known that crime known to police and crime that occurs are not related. We have known that for more than 100 years. And yet, we have to learn that lesson over and over again, especially as we gain access to new and different data sources. It is so tempting to assume that we know the answer to the question we're trying to ask. Okay, so what's the difference between graves and policing? Because in the work in Mexico, we and our partners concluded that that classification model was an improvement on the status quo. And in our critique of predictive policing, we concluded that that was not a good use of essentially the same math. And the thing we ask ourselves is, what happens when the model makes a mistake? When it classifies something as either a false positive or a false negative. We know these models are going to make mistakes, otherwise they're not telling us anything new. In the case of graves, a false positive means we waste some resources. And a false negative means we miss an opportunity. And again, in close collaboration with our partners, we concluded that that was no worse than the status quo. As the situation on the ground in Mexico evolves, we may change that decision, but that's the state of that project right now. Whereas in the case of predictive policing, a false positive means a neighborhood is systematically over-policed. And if we want to generalize that to other applications of these tools, the rubric that our team advocates for is asking this question of what's the cost of being wrong? Do we waste resources or do we affect people's lives? And who bears the cost? Is it the organization that created the tool, or is it the community that is having the tool used on them? And this, again, is where community involvement is crucial. We cannot leave it up to ourselves to answer these questions. We have to ask the communities who are being affected. They are the ones who know the answers to these questions and who are going to have insights that we may not have. Now, beyond this rubric, I have been starting to think, well, that question helps us to identify applications that may be harmful and applications that may be helpful. But how do we skew ourselves and identify those most helpful situations? And I've been really starting to think that a lot of problems are classification problems that I didn't sort of see in that framing. And this is really thanks to a lot of work that my colleague Tariq Shah, who's here somewhere, has been doing. And this brings us back to his technical blog post on scanning documents to uncover police violence. As you heard Trina describe, many of our partners are in a similar position where they've gained access to a cache of documents, but they've been turned over because that organization was compelled to share that information. So they share it in the least convenient way possible, and it needs a lot of processing. And it turns out that processing documents can be a classification problem. You can classify where the beginning and the end of a document is. You can classify, does this page contain a name? You can classify, does this page contain an age? And it's a very iterative process. It requires the kind of human reflection and human labeling that Trina was talking about. But it is a way to leverage these machine learning tools and human input to process and make sense of this incredibly valuable information in a way that I don't think we could do either purely manually or purely using machine learning models. And so I just want to close by returning to the amazing work of the Beneath the Surface team that I really think is the use case we should all be trying to replicate. We should really be thinking about the kinds of documentation that may exist, that may be accessible, and that then can be processed using these tools and by involving the community that's affected, so that we hear reflected back from them, what's the meaningful content? What are the meaningful labels that we need to use to build our machine learning models so that we're getting the right kind of information out of these problems? I will leave it there and say thank you very much. There are many ways to follow us and our work, and I really hope you'll all stay in touch.